y'all, welcome back to my channel. Today's video is part 2 to the one I posted yesterday. I'll be referencing some of the things I talked about before in this video, so if you need a refresher, I'll link it above and in the description. So let's dive right in. To start, we're going to build the 3 logic statements that we learned about last time: and, or, and not. Before we start though, there's one issue. These statements are in terms of true and false, which Redstone doesn't have. So how do we apply these logic statements to the block? To do this, we'll just change the meaning of 1 and 0. Instead of 1 meaning true, it will mean on, and instead of 0 meaning false, it will mean off. So, looking back at our T-charts, all of the 1s now represent the redstone being on, and all of the 0s represent it being off. So now let's actually build some stuff. I'll be using levers to represent the inputs, and redstone lamps to represent the outputs. If the lever is on, and remember, this is shown in our T-chart with a 1, then we want the redstone lamp to be off. If the lever is off, and this is the 0 in our T-charts, then we want the redstone lamp to be on. I would also encourage you guys to try this at home before watching the rest of this video. So let's start with the not operator. All we want this to do is change the input from whatever it was before. So we'll start with just placing down our lever and a lamp, and then some redstone dust. Now, we know that when the lever is off, the lamp should be on. So I'm going to put a redstone block at the end of this line. Now all we need to do is move the redstone block when the lever switches on, which will stop any power from getting to the lamp. We'll use a sticky piston because we want the system to reset after we click the lever, and just connect it on up to the lever. Now we have a not statement in Minecraft. I'm just going to clean this up and make it smaller, and we're left with this. When the lever is off, the redstone lamp is on, and when the lever is on, the redstone lamp is off. This lines up with the T-chart that we made in the last video for our not statement. Okay, now let's make an or statement. So before we start placing anything down, we have to remember that the or statement and the and statement have 2 inputs, which means both of them are going to use 2 levers instead of 1. So again, we'll start with placing down our levers and our redstone lamp. And then we'll just add some redstone dust so we can see where the power is coming from. Now, we want the lamp to be turned on when either of the levers is turned on. So I think we'll use redstone blocks and sticky pistons again, connecting them like this. Now, when the lever is turned on, it'll make the piston push the redstone block next to the redstone dust and turn the lamp on. The same is true when you click the other lever, and also when both levers are pressed. Again, I'm going to go ahead and remake it as small as I can, and we're left with this. Finally, we have the and statement. This one is a little bit harder because it needs to work only when both of the levers are turned on. This one also has 2 inputs, so we'll start with placing down our levers and then our lamp. I decided to use a comparator for this one, which essentially compares the strength of the power coming from 2 different sources. Now see, if the power coming from this source is stronger, then it continues through to the lamp just fine. But if the power coming from the other source is stronger, it stops it from flowing through to the lamp and keeps the lamp off. So I did something similar to the not statement, with a piston moving a redstone block away from a connection. When both levers are off, the redstone lamp is off as well. Turning this lever on starts supplying power to the lamp, but because the redstone block is closer to the comparator, it is stronger and stops the lamp from turning on. Turning on the other lever moves the redstone block and disconnects it from the comparator. Now this lever is the stronger source of power and the redstone lamp is able to turn on. Lastly, I'll simplify this as much as I can. And there we have it. So what could you potentially use these statements for? Not can be used when you only want something to happen under certain conditions. Let's say you have some lights that you only want to turn on during the night. So you could use the daylight sensor and connect it up to your not operator. Now, during the day, when the daylight sensor has a large signal, meaning that it is on, the lights will be off. During the night, when the daylight sensor has a small signal, meaning that it is off, the lights will be on. The or statement could be used if you want to have 2 levers that do the same thing. Maybe you would have a door that is open with a button, but you want to be able to open it from 2 different places. The or statement will make sure that the door will open when either button is pressed. You can use the and statement to make sure that something will happen only when very specific things are pressed. For example, you could build a giant protected wall around your base and make it so that the only way to open the gate is for you and your friend to both be standing on 2 pressure plates that are really far apart. This way, the only way for the gate to open is when both you and your friend are standing on the pressure plate. Now let's take a quick look at how these statements look in the programming language Java. The not statement is shown by using an exclamation point. So this right here is literally not x. It can be on, off, or really any variable that you want it to be. Or is represented by two vertical bars. You will have one variable before the bars and another after. Again, these variables can be anything, but you can use these to run specific lines of code when at least one variable is true. Lastly, and is shown by two ampersands. This can be used to run certain parts of the code only when multiple variables are true. You can also use multiple statements at the same time. For example, this will return as true if either not bad or cute is true. This will return as true if it is both cool and either blue or red is true. So there you have it, an introduction to Redstone using our knowledge of binary. I hope this was helpful. See you guys in the next video.